Well, welcome everyone. It is a terrific Tuesday, and I'm excited to share with you today .NET AI architecture for DevOps. I've been speaking about this topic for a long time, and and we have a really good crowd today. I'd like to turn your attention to the chat window, and uh, Kaylee is kind of in the back channel, going to be sharing some links as I mention things and a few things that we have that might be interesting to everyone on the training today. And also, um, the we have a Q&A window here in the Zoom for you folks on live. And so um, there's a reason that you came today. There's a reason that you're here thinking, what do I need to know about DevOps and how does the architecture of my DevOps environment change, or how do I need to be thinking in the world of artificial intelligence as applied to computer programming? And so you all came with certain questions. And what I'd like you to do is just um, so that I can make sure to work them in. I'd like you to put those questions in the Q&A window. You came with a particular question, with a particular issue that maybe you're wrestling with, you're talking to your teams about. And so, what are you thinking about in this topic? How should AI affect our architecture? How should AI, because of AI, what should we change about the way that we plan, build, change software, deploy, monitor, set up our development environments, our testing environments, everything surrounding how we do a good job at shipping good custom software. And and even if you don't know how to frame it as a question, you can just frame it as I'm thinking about this. I'm thinking about this topic or this angle of it. And so if you wouldn't mind, go ahead and put that for me in the uh, Q&A window or the chat. Either one is fine, and that'll kind of help me serve you as we go through the topic today. All right, thank you. I see him coming in. Yeah, go ahead and just keep him coming. I'm gonna roll on this. So the agenda today, I'm going to cover three areas. I'm going to talk about AI-driven development and encourage you how I think that we should be thinking about it. I'm going to talk about some architectural elements for language model integration with our software and with our DevOps environments. And then also um, talk about how DevOps environments need to change for AI-enabled systems or AI-driven development. My latest book is about software leadership. Here's a QR code. If you or a teammate would like a free electronic copy of my latest book, you can just use that QR code, or you can use the chat, use the link that's also in the chat. And you can find it on Amazon, hardcover, softcover, Audible for audiobook, as well as on Kindle for ebook. So um, you can find it anywhere. Now, let's dive in. Let's dive in and let's look at some of the studies that have already come out with software development being impacted by AI coding. All right. So this is a study from the first year in 2024. We're still waiting for some good studies out from 2025, but there's a lot of people and probably everybody on this call that's already using some type of AI coding tool to help do work. And for a lot of people, it's replaced a lot of Google searches, a lot of browsing on Stack Overflow, and it just helps things go. So here's some changes that have been found. The blue is positive, the orange is negative, but these are the percentage changes in that particular area. So individual effectiveness. In the survey, everybody was reporting that individually, I think that by using these AI coding tools, I'm somewhere between 15% and 20% more effective. That looks like about 17%. All right, great, fantastic. Let's jump down. Code quality. Hey, I think I'm around 7% better code quality, a little over 5% better product performance. Team performance is about, 2.5, 3% better. That's great. Burnout and friction are so close to zero that they're negligible. But let's look at software delivery instability. That's the one that we need to be wary of here. And well, the respondent said, "Hey, I think I'm 17% individually more effective. However, my software is getting almost 10% more unstable. That means more bugs, more problems. Now, anybody who has turned Copilot or Claude or Cursor loose and say, hey, generate me some code, knows that without some really good grounding and some guardrails and being specific about architectural elements, we can generate a lot of bad code. And if you point it to a repository that you have that you don't like, where that piece of software, you don't like the code in that piece of software, the code is hard to read, it's hard to change, unmaintainable. You may, identify it as a lot of technical debt. You may call it a legacy system. Nobody wants to change code in that piece of software. The code is just really, really hard to understand and change. If you point an AI coding tool to that repository, it is going to generate a lot of code that you don't like. Why? Because it is pattern matching against the code in the repository, and you don't like the code in the repository. So it's going to give you more of what you already have. But if you point it to a Git repository that has good structure and is readable, and you like the code in that Git repository, well, guess what? You're going to get more of what you already have. And if you like that code, then you're going to like the code that the AI coding tool gives you. So that's really important. All right. So that's something to keep in mind. Now, I want to go over the really important structure for a DevOps environment. If you've been following our training series, you've seen this before. By the way, this is the top third of our DevOps architecture poster. If you'd like a high resolution PDF of the entire poster so you can send it to a print shop and get it printed, then by all means, Kaylee will help you out in the chat. And it's important to have a complete DevOps environment. The world of AI-driven development does not change the proper process for making a change to a piece of software. And making a change includes, setting it up from the start. You can talk about greenfield versus legacy, but greenfield is only greenfield for a very, very short period of time. And once you set up the initial skeleton, the initial structure, and then kind of start adding code and modifying code, greenfield is gone very, very quickly. So the normal state of software is making changes. And you need all of these stages in order to make changes. You need a full continuous integration pattern, and then you need automated deployments, and you need monitoring. Okay. Let me harp on continuous integration just for a second here, because so many teams and articles out there will have you believe that continuous integration is an automatically triggered server-side build. Well, that is so myopic. That is one tactical piece of the continuous integration pattern. By the way, if you've never read the book that defined continuous integration, it was published in 2006. And go read it. It's literally called Continuous Integration, Addison Wesley Publishing. And there are three stages to the continuous integration pattern. It's a design pattern. There are three stages. The first one runs on your local computer. The second one runs on a team server. And the third one runs on a deployed environment specific to your application. So, step one, the commit stage. Your private build is your main tool in the commit stage. This runs on your local computer, and this answers the question for you. I just made a change. With what I just changed, is the code base still stable or did I mess something up? Right? That's an important question to know the answer to. All right. So you're still stable. You run the private build. Of course, the private build script is going to run, it's going to do the compilation. It's going to configure your local developer workstation so that you can run tests. So you have a SQL Server database. It's going to create the schema of the SQL Server database from the scripts that are in your source control. And then it's going to run your unit tests and it's going to run your component level integration tests. It's going to run your fast integration tests, however many tests that are feasible to run in a 5-minute period of time, no more than 10 minutes. You need it to be fast, otherwise you won't run it very frequently. All right, but then you're confident in checking it in. You know you haven't hosed anything, and so you say, "Oh, I'm ready for the integration stage. I'm ready to share this code with my teammates." And so even if you're on a feature branch, you commit, you push, and now you have the integration stage. Primary tool for that is the integration build, and that is going to rerun every step in the private build on the team server so that you don't have a, oh, works on my box type of thing. And you're going to run it on a team shared environment. And you're also going to be mixing, that's the first time you're going to mix the code with the code of your other teammates, because in the meantime, your teammates have pushed some code, maybe some pull requests have been merged into master. And so now your feature branch needs to be back merged from master. And then you run the integration build, again, those compilation, unit tests, integration tests, building of the database. And then you add in things like linting, you add in static code analysis, um, any other static code checkings, code coverage, and then you build your release candidate and you package up a set of files, your release candidate package ready for deployment. And that the integration stage answers the question for you with what I just changed, mixed in with what my teammates changed. Do we as a team still have a stable piece of software ready for deployment, or did something get messed up? All right. So let's say it's good. Then you merge into master, you do a pull request process, talk about formal inspections for pull requests later, and then uh, you merge it in, and the process happens again on master, and then the third stage, which is the first deployment, and we deploy automatically the new builds because we need the answer to the question: with this new build, will it still deploy? Will it still start up? And will it still do everything that it used to do? Uh, because I think anybody who's been in computer programming for a long time has had the embarrassing occasion where we deploy to some sort of test environment, we think we're good, and then we tell someone in product management, we tell a customer, hey, this thing is ready for test, go ahead and look at it. And then they go and pull it up, and the very first screen blows up spectacularly in their face with a really ugly exception. Nothing more embarrassing, right? And so we need to automatically deploy, and we need to have a test suite which runs every feature of the application. I call it a full system acceptance test suite. Um, and in that way, you have the confidence. So that is the continuous integration pattern. That doesn't go away just because an AI tool generated a change for us, because we still need the answers to those questions. We must have the answers to those questions. The AI coding tools don't help us at all if we don't have the answers to those questions. Do I still have a stable code base? Does it still do everything that it used to do before? And now, of course, hey, do I have a new behavior? Do I have a new feature? All right. All right. And let's do, I want to show you, I want to do a 10 AI tool analysis for you just to kind of show you the landscape. And because ultimately we want to be able to delegate a feature to the computer. Now, if I were to, put away PowerPoint just for a second and open up Visual Studio, I have a session here on Visual Studio in public repository that I use quite a bit. It's not important. If you want to peruse it, github.com/clearmeasurelabs/bootcamp. And by the way, I know it's short notice now. We only have a few spots left, but in 3 weeks, the first week of March, and Kaylee's going to put the dates in the chat. We have a few spots left for my advanced .NET architect and engineer boot camp, and it is in person 2 days of immersive, intense boot camp style training. I did a course back in Austin in August, and now happening again. It is in Austin, Texas. We are at a beautiful resort with a conference room overlooking Lake Travis, view of the water, really nice place outside the city. And we have just a few spots left. And two things. Um, register for it and come. And we are giving away one seat free. We're doing a drawing. So we're doing another draw. We did a drawing a few weeks ago and we awarded the winner. We're doing another drawing. So if you would like to enter into that drawing, then you can work with Kaylee in the chat and she'll take your name and we'll be doing that over the next 10 days drawing. But if you want to absolutely secure a spot, just go ahead and register. I mean, as far as training goes, pretty darn cheap, and you can see all the details. Okay, we're all used to using Copilot in Visual Studio like we see on the screen. And by the way, this is a session where literally the prompt, because I'm doing this over and over again, so I want to tell it, hey, create a new branch. And you can refactor some of these back into Copilot instructions. But ultimately, we want to just be able to give it a prompt and tell it, hey, let's go ahead and delegate a change to the computer and have it just go ahead. Another way that we might want to do this is if I just open another tab, and I don't want the pull requests, I want to just go to the repository. Another way to do it, or our pipe dream. Come on, GitHub. What are you waiting for? Pretty sure that was right. Yeah, let's see. Go to issues. Is GitHub down? That's strange. That's not that's not good at all. GitHub's not responding. Interesting. Okay, that came up. Nope. Well, if I'm still connected, yeah, somebody in the chat give me a signal that I'm still connected and it wasn't my box, but um that's not a good speed right there. GitHub is up for me. Yep, okay. So maybe it's just an intermittent. Huh. Interesting. All right. Well, I'll have to come back to that. I'll have to come back to that. But I want to give you a 10 tool analysis. So Visual Studio, and you probably used it inside VS Code. Let me close this down. Over here on the left is actually in the middle is open code. It's open source. And right now I have it configured for Grok Code Fast 1. I was experimenting around with that, and you can select. It has, there's a few free models, and you can go to all the Claude models. You just put in your API key and do that. That's open code. If you've never tried out open code, try it's the free one. You just need to have a language model provider. On the right over here is Claude CLI. On the left is Copilot CLI. And you can see on the left, I just popped it up and say, hey, run my private build, which is behind private build PS1. And it succeeded. All 38 tests passed, and it took 28 seconds. And on the right, I just did a test session where I ask it to go to an existing screen and add a new field to the screen, add an instructions field to the work order, because the application is a work order application. So pretty simple domain. And you can see the things that that it changed. Here's the entity framework mapping. Here's some web screen in the Blazor WebAssembly app. And then at the bottom, it's even authoring some new tests. And then here's all the changes made, and it made a new pull request. All right, so those are the command line tools. And then you have Cursor. If you've never used Cursor, the unique thing about it is it's actually a fork of VS Code. So the shell literally is VS Code. You can install VS Code extensions and all that stuff. And so you can browse the code. But what's unique about it is you can have multiple different agents going at the same time. And within each agent, you can literally give a prompt. So I literally gave the prompt, work GitHub issue number 45. That's it. That's the whole prompt. But issue number 45 had all of the instruction. It had a full specification in it, but that was the only thing. And so I told it to go and use Sonnet, Haiku, Gemini 3 Pro, GPT 5.1, just to compare the things. And you can see the session and you can see the changes that it made. And if you've never done this before, then you literally give a work GitHub issue 46. And then you can say, give me multiple models, and you can literally select the models that you want it to use, Opus versus Sonnet. And you can test it. So if I just kind of kick it off, then it's going to do a new session. We're not going to wait for it here in this webinar, but it's going to basically build the same feature. Issue 46 is the same feature. It's just a copy. And it's going to spin these up, and you can kind of click around and you can get to know what each of these models do. And it's calling GH command line view issue number 46, and it's pulling the information from GitHub issue 46. You can see what GPT 5.2 Codex does versus Grok Code. Oh, Grok Code had an error. Okay. So you can learn what the different models do, because the coding tool is just a wrapper, but the model is kind of the uniqueness. All right. So another way that you want to be able to work is to, and I guess I just had a little blip with Copilot. You want to be able to create a new issue. And so if I create another issue, and this is a work order application, let's see, I don't know, uh, uh, make the login button blink red when no user logged in. All right, that's just some contrived. I just made it up on the spot, right? And I'm just going to paste it in here. All right, but that's simple. Now, when we have an AI-driven DevOps architecture, a DevOps environment enhanced with uh, a DevOps environment enhanced with AI-driven development architectural elements, then I should be able to take the easy stuff and just delegate it to the computer, right? Now, I could say, can I assign to Copilot? I'm sure all of you have assigned to Copilot, and you'll get a feature branch, and Copilot will start working on this cold. But language models are not good at doing more than one thing at once. You get a better result if you break down the process and do all of the normal steps of your software development lifecycle, and you use the language model to automate one thing at a time. And so, what's the first thing we do? Anytime there's a little blurb like this, what do we normally do? We talk to the product manager and we pull up the screen and we look at it and say, okay, I just want to make sure this is what you mean. All right, but we kind of break it down and probably just verify, look, we're not going to do any logic changes. This is only going to be a CSS or markup change. That's it. So wouldn't I love to be able to just, label it? Okay, I've already defined the conceptual definition. The UX design is kind of already done. So let me put it in technical design. All right, so if I give it the label of technical design, then I would love for the computer to just spring into action and start working on this. All right, let me put a pin in it, and I'm going to come back to that. So I wanted to do let's bring up the PowerPoint again. Shift F5. Okay, have to bring up the PowerPoint and get that back on the screen. There we go. All right, 10 tool analysis. So I'm gonna come back to that. We looked at, let me get to the right slide here. We looked at a few, but here are kind of all the popular ones. And of course, there's going to be more coming out. What's important to know is architecturally how these are set up. You got Cursor, you got VS Code with Copilot, you got Visual Studio with Copilot, you got Claude.ai, you got JetBrains Writer with Junie. You have the GitHub Copilot coding agent that runs on github.com. You've got a Claude agent that can run against github.com using GitHub agents. And then you even have the Claude Code iPhone app. And then you have Open Code, which is CLI. What's really important is to understand the architectural differences, which two really important things. One is where is it executing? And the second is what operating system is it using? Because most of the time, the systems that we're using, everything has been on Windows for so long. Now, you probably got some applications and container-based things that are perfectly happy deployed on Linux containers and whatnot. But there's so much software that we have where literally it's never even seen Linux. It doesn't know how to spell Linux. Everything is Windows bound. Everything in the builds and the testing is Windows based. And so for the operating system where you have Linux, until you make everything about your DevOps environment and all of your build scripts Linux compatible, those AI coding tools are not accessible. Okay. So if you want to use GitHub Copilot coding agent and you haven't tested all of your build scripts and configuration scripts and private build and integration build on Linux, then Copilot Coding Agent is going to be coding blind. It's gonna make some changes. It's gonna suggest things, but guess what? It has no ability to run your private build, your integration build, stand up a SQL Server database, run all of your tests, do everything that you personally are used to doing, which give you the confidence in the answers to the question, do I still have a stable code base or did this change mess something up? And it doesn't do us any good to have an AI coding tool make some changes and then for us to manually have to go and somehow figure out the answer to that question. Do I still have a stable code base or is something completely hosed up? When we start considering a change set that the computer generated for us, we should not waste our time with it unless we absolutely know the answer to the question. Oh yeah, this is stable. It works. Then we're kind of thinking, does this completely satisfy the business need? Let me make sure that it stuck with the architecture that I'm going for. Let me make sure that I can read the code and it's readable and not just generated, gibberish that's unintelligible, right? But you should not be wasting any of your time on a change set where you don't know that it's absolutely stable. So, so if you're going to want to use Copilot Coding Agent or Claude Agent, then you need all of your existing DevOps assets to be Linux compatible so that in your Copilot instructions, you can have the agent run your private build script that then runs all your unit tests, integration tests, spins up a Docker container with SQL Server for Linux, builds the database schema and all that. Okay. Also, you want to make sure you know where it's running. Now, Cursor Agents, it runs on the local workstation. Now, there is a hosted Cursor option where you can run it on Cursor VMs. That's going to run on Linux, just like Copilot Coding Agent, and that's available to you. But you can run multiple Cursor agents locally. So if you got a powerful computer or you have a spare computer, you can have multiple things going, kick some things off, go to lunch, come back, and you need to hone the instructions so that so that the tool does not report complete unless your private build script ran successfully. Because again, you don't want to waste your time. Now, if you're going to run multiple tools or multiple agents locally, then you need to enhance your private build script so that you can run multiple instances of it side by side. Now, the main conflict here is going to be your SQL Server database. For the longest time, if I'm handcrafting every line of code, well, I'm serialized. I'm gonna run one private build at a time because I'm only working on one thing at a time. So I just would in this for this application, it's the name of the database is Church Bulletin because it's a church work order application for the First Church of Springfield themed for The Simpsons. And so my name of the database is Church Bulletin. And guess what? I can only have one on my database instance, but that's all I've ever needed. Well, if I'm going to delegate to the computer and have it running locally and have them running side by side, then and but as well as those things going on, I'm working on something. Well, I'm going to run my integration tests whenever I want. The coding tools are going to run it whenever they want. The database is going to be blown away and recreated whenever it wants. So I have to parallelize it. And so on the bottom left, you see that we have Church Bulletin with a timestamp and some unique identifiers. And so in this example, we've enhanced the private build to create a uniquely named local database so that I can run my private build in parallel and they don't step on each other and have false failures. So that's something that you need to think of. That's an enhancement to your DevOps environment to enable the same computer to run multiple instances of your build scripts in parallel. That's important. Okay. Let me come back. Let me come back to where was it? Here we go. The new issue. Let me refresh. Did I even save? Oh, I didn't even create it. Look at that. I didn't even create it. Okay. Now I've created it. Now I'll come back to it. All right. Because it was going to do something. All right. Jeff Sutherland, one of the co-creators of Scrum. I interviewed him on my podcast a while back, and we were talking about AI-driven development. And he said he started talking about extreme agile, and he was talking about the principles of agile in the world of AI-driven development. And he's predicting that by 2030, teams will have to be 30 to 100 times faster than they are today. Now, this is a guy in his 80s who's got a wealth of wisdom. And when he said that, I was listening intently because he knows what he's talking about. And CFOs everywhere are struggling with the overall cost of software. You see the announcements where, oh, AI was going to write all this code automatically. And so what all these companies do, they start making plans to, cut developers because they believe the bunk that AI is just, that AI stands for actual intelligence instead of artificial intelligence, when in some cases you don't know what you're doing. You look like an absolute idiot. So, but what I'm thinking about is businesses need the cost of custom software is untenable. So software projects have to come down in price. And we have a technology that is going to help us do that. Not that any good programmer is ever going to be out of a job. I mean, we're 4 million developers short worldwide. No good developer is ever going to be out of work, but this technology is going to help us, is already helping us deliver more projects. And so at the bottom end of Mr. Sutherland's prediction is 30 times faster, not 30%, 30 times. Okay. That means that something that would take me 30 days to do, well, now I need to be able to do it in one day. What does that mean? That means that for that to happen, I have to have a DevOps process that doesn't require me or some member of the team to set eyes on literally every single line of code. Because if I have to read every single line of code, and this is a big, if that's what it means. In order to get 30x, I don't even have the capacity to read every line of code. Imagine how much code would you work on if you were just going building stuff for 30 days straight? How long would it take somebody else to read the code and understand it? You can't do it in one day. You can't even read all that code. And so we have to imagine, we have to pull forward lessons from other automated building industries where they don't have an inspector inspecting literally everything. They have barrages of tests and automated validations, and Dell has computer burn-in tests, and the Tesla factories that build the cars, those are fully automated. I mean, the cars are put together by robots, and every insertion of every component is not manually inspected. Instead, the car is tested and proven to be working as a whole, and then we know that it was put together. Now, we have enough static code analysis technology to be able to evaluate architectural patterns and NuGet packages and all that. The most important thing here is we will never get the productivity promises of AI-driven development unless we finish the DevOps journey. The DevOps journey started by by the need to expand what agile engineering gave to coding and expand that into the world of systems engineering, the systems engineer. The original word for DevOps um, was supposed to be agile systems engineering, but of course that doesn't roll off the tongue, so it became DevOps. DevOps is not about development teams and operations teams coming together. It's never been about that. It's been about engineering. Okay. It's been about engineering. Engineering is what propelled the agile movement through the adoption of automated tests, automated builds, automated deployments, and then DevOps carried it forward to automated environment configuration, automated environment creation, ephemeral environments, what became open telemetry with traces and events and metrics and log centralization. Okay, it's always been about engineering. So engineering is what's going to carry us forward to applying artificial intelligence to 30x productivity. And in order to do that, we have to have a complete DevOps environment that answers the question, something changed. Do I still have a stable piece of software, or is something messed up? Because if we're gonna delegate to the computer and the computer is gonna make a change on a feature branch, we need the answer to that question, the unequivocal, factual answer to that question, so that we don't merge a feature branch that hoses up our master branch. That's important. So we have to we have to figure out the architectural standards, the design patterns, the absolute consistency, so that we can take advantage of the world where for the easy stuff, for the big old pile of easy software changes that would just suck our hours and days, we can delegate it to the computer, and we have an AI enabled DevOps architecture that can take an easy change and just take care of it, and yield a change set where if we were to manual, and of course initially until you get it set up you have to manually inspect it, but you like the code that you say, oh yeah, this is what I would have done, this is what I would have done. So if we come back, I think that, yeah, let's come back. Okay, so I hadn't saved the issue before. I'm going back to GitHub, and I created that make the login button blink red when no user is logged in, and I set it to the label of technical design. Well, guess what? I have implemented some AI-driven DevOps um, architectural elements in this GitHub repository where I have AI agents that just kind of pick it up automatically. And it took it from technical design through test design onto development and then delegated it to Copilot coding agent. And it's probably in process. So what does that mean? Well, I gave it just a little bit of information. This is an easy change. And so I automated the process of tasking out the individual development tasks. So I have an AI agent inspecting the code base and then breaking out 4 independent things that need to get done and then verification. And then for the test design, we have specified some more full system acceptance test scenarios so that when we write the code for this, we also are expanding our test automation appropriately. And we have, test scenario, login button. When the user is not authenticated, blinks red. The login button when the user is authenticated does not blink red. And, some steps in there. So 1, 2, 3 tests. And of course, you have to hone your own system, your own DevOps environment so that these things come out right. And then what happens, we change the labels to change the status along the way. We assign Copilot, and then of course Copilot creates his own draft pull request. And now Copilot is in the process of changing things, and it looks like it's made some good progress. And if we scroll down, yep, it's still working on it. You can actually view the session that Copilot is using and just see if it's running, take screenshot. Okay, it did a whole bunch of stuff. And we're not going to go through this, but you want this to be completely automated so that this pull request, you never even mess with this pull request until at the very bottom, like normal, you see that the checks are all green and that the automated review has already happened and we're ready for merge if I want to. So if I go over to a pull request that's already gone through the whole process and click on this one was creating the instructions field. You should be able to go to the checks and you see that the checks were green. Now, what are the checks? The checks are our continuous integration process. How we ran the integration build, then we packaged up for deployment, then we deployed on our test-driven development, our TDD environment, our test automation environment, and we ran our full system acceptance tests. And then we do some, Claude review. Maybe we do a cursor review, and all the checks are green. If all the checks are not green, if I go over to, if I just go back, where was I? Right here. If I go back and I don't see that green check mark, I know not to even waste any time with it. Okay. And so what you're doing is you're taking all of the steps. And if there's a step in your DevOps process that can be automated, you're automating it. Yes, we have this great AI language model technology to work with, but what have we done with computers ever since computers were around? We use it to automate things that we used to do with our own fingers. That's kind of, business machines, that's what we do with machines to automate things that we just have to do manually. Okay. So let's keep going. Now, I've harped on defects. You never want to mess with some AI generated code unless you know the answer to the question, do I still have a stable code base or is something broken? And why it matters? Defects are the worst thing. Defects steal time from your team. If you're going to get the advances of AI-driven development, you have to have a complete DevOps environment. A complete DevOps environment shouts from the rooftops that something is broken right when it happens. You don't require manual testing just to know that something's broken. And when you get notified, well, guess what? You just did something just then to break it. So it's really easy to just undo it. You thought you were taking a step forward, but you weren't. So let's quickly take a step back and let's try again. We have the automated test, the linting, the static analysis, the automated packaging and deployment. All these things will break if something's hosed. And so by having the language models and the AI coding tools work in the exact same process as you do, when something breaks, and it will, that error message flows into the context of the language model session, and then the coding tool knows, oh, there's a problem, can do a few more turns, resolve the problem, and now, oh, okay, resolve problem, now move forward. That's super, that you have to do it. And so part of having a complete DevOps environment is planning your work, about having work tracking. And so you see this development column in the middle where you actually, write and change code. Well, that's the sandwich. That's the binding of your process. Everything folds. The stages before it are decisions that you make so that when code starts changing, it's the right code. And then the things that you do after it are verification. It's things that need to be checked to make sure that what was changed is good. Okay. And there are four types of design decisions that need to be made by somebody before you're ready to make code changes. And I don't care what you call them. The first one I call conceptual definition. It's business requirements. You need to figure out why it's important to make this change, what it impacts for the business context. And then after that, user experience design, you need to decide how a person is going to experience that the change now exists. Even if the change is just moving some back-end data from one place to another, the user experience is going to be whether the user has to wait 5 seconds for some data to be refreshed somewhere, or whether the user might need to wait 24 hours for the data to be refreshed somewhere. But every change that you're going to make has some type of user observable behavior in some way, even if it's just data moving in the background somewhere. So you need to decide, how is the user gonna know or experience that this change is made. Then after that is technical design. And this is evaluating if the architecture is sufficient for this new feature, or if maybe we need some new architectural elements. Do we need a new NuGet package? Do we need a new design pattern? And what are the technical steps to actually do this? So we start breaking it down into technical steps. And then test design, that is where we finalize the definition of done. What is in scope? What is out of scope? Because if we have a complete understanding of what we're going to change, we should be able to specify some full system test scenarios that verify that the in scope behaviors work, and we should draw the boundaries of things that are not in scope and we don't need to test. Armed with those four design decisions, well, now we can write the good code. And guess what? When you have good detail on all those four design decisions, pretty much any member of your development team can write the proper code to make that change. And turns out that when you have all of that information, the AI coding tools actually also do a pretty good job, as long as the code that you have is code that you like, because the coding tools are going to give you more of what you already have. So that's how it goes. And then functional validation, you want to make sure that you have complete coverage of your entire piece of software in an automated way. Otherwise, well, guess what? You're going to have to manually check it. Anything that you don't have a mechanism to be automatically checked, you're going to have to manually check. And if you have to manually check something, literally every build, you won't be able to do it. And you will not be able to take a 30-day project or a 30-day load of work and shrink it into one day. Now, if that's too far-fetched, just think about two. How do you get 2x improvement? How do you take something where, hey, you know what, if I were to, handcraft every line of code, it would take me 2 days to do this. But how do I shrink it into one day? It's the same thing. And once you start squeezing out the places where defects might slip through, you start going faster. And then you figure out how to use this new AI technology to automate a little bit more. Okay. All right. So let's come back to let's come back to this. While I want to answer the bits of some of these questions that came in. Um, there we go. All right. Um, for current computer science undergrads, how can we allay their fears about AI and prepare them for the workplace, integrating AI in the curriculum? Well, I think I mentioned that we're still 4 million software developers short nationwide, and the gap seems to be growing. We are not in jeopardy of having too many software developers worldwide. And I stand by my statement. There is no good there is no good computer programmer who is going to be out of work. Uh, let's say that Mr. Sutherland is right, and we get to the 30x and we're going beyond. Companies are not going to say, you know what? Yeah, I think we have enough software. No, companies always have continued to compete aggressively and invest aggressively to gain market share from competitors. If we can do 30, let's see, good software let's say you did a quick hit software project of 3 months and you could do 4 projects in a year, and now I can do one project a month or one project every 2 weeks. If I can do software projects at the rate that you can think about it, companies aren't going to do less software. They're going to do more software. And so nobody is going to be out of work. It's just there is going to be an explosion of custom software, and it's already started. Mark my words. All right, next question. Trying to get a good feel for how to add AI to an existing legacy business application that is hosted by multiple companies on premise. All right, let me actually I have a slide talking about that. Let me go to, here we go. You're going to want to on premise. So if you want to host a language model on premise, you're not going to be able to host the premier language models because they just require too much hardware to be practical. But you can do some simpler things by hosting some of the local models running through LM Studio or Olama, and your code is going to look something like this, where you still segment off your data store, which is now your model file, but you have a read-only model file. Now, I compare it to SQL Server because in SQL Server, we have an MDF file, but no application code ever goes and says, where's the MDF file? Let me open it up. No, instead, we have SQL Server, a software product that opens it up and keeps it open and reads and writes to it. Well, the LLM servers, in our case, Olama or LM Studio, that is akin to SQL Server. It opens up the model file and reads from it. There's no writing to a model file, so it's just read only. Our code, just like we use Entity Framework to talk to SQL Server, we don't handcraft queries anymore. We use Entity Framework to talk to SQL Server, and it kind of translates back and forth. Same thing with Microsoft extensions for AI or semantic kernel. We use .NET libraries, just like Entity Framework, to talk to our LLM server the same way. And so your hosting model, you would put Olama on a computer somewhere that has at this point, one of the NVIDIA AI GPUs, so that you have however much hardware you need, and you would run one of the models, and then your code would just point to that computer on your network, and it would use libraries. So you're just going to be bound to how much hardware that you can afford and what type of model that you can get your hands on. It's probably not going to be practical. No, you could license the open AI models, but that's out of the price range for most companies, I think. All right, next question. We have decades of business data in our production app that we should be able to use, but that data is not visible to developers. So how can I get the smarts of production data into our development data? So if you have sensitive data in production that you don't want developers to see, then you're going to have to desensitize it. Now, Redgate SQL Clone is the best product that I'm aware of to to desensitize and mask some of the sensitive data fields and essentially clone from production to a test environment and then do a little bit of desensitizing so that you have so you have the right shape of data in order to be able to do that. Another question, I'm also looking at automated tests with AI. How do you trust the AI that the AI is going to do what you think it will do? Well, I don't trust it at all. In fact, I don't even trust myself. I don't trust the other programmers on the team. I think it's important to explicitly not trust because once you start trust, you just start assuming that it's going to be okay. And once you start assuming that some member on the team is not going to do something wrong, not going to make mistakes, well, then you ship a bug to a customer. So when you're talking about a DevOps environment, I don't care if it's Joe or Bob that's making a code change, or if it's Joe's, Claude bot that's running on a computer while Joe is at lunch. Doesn't matter who is making a change set. I don't trust it at all. We have to have complete, comprehensive, automated verification. Then I trust it. I don't trust that if we make a change, I don't trust that the application is still working unless I actually put the application through its paces, unless I actually deploy it to a representative environment, load it up, click through on the buttons, go through all the transactions, type in every text box. Only then do I have confidence that the application is still working. So I think it's a mindset. We can't trust anything that was changed. We have to verify. And that's not just because it's AI. It's because that's just what it is. I mean, I make mistakes. I don't want you to trust the code just because I'm the one that did it. No way. All right. Any experience with greptile? No, I do not have any experience with greptile. Sorry about that. Um, all right. It looks like we got through it. So as we close up, thank you all for your engaged questions. Just those were a few questions that I hadn't gotten to. I'd worked in the rest of them. So fantastic. Oh, another question. If I did not win in the drawing for boot camp in the last round, can I re-enter for this next round? Yes, you can. Yes, you can. Okay. So as a reminder, we're going to do a drawing in the next 10 days for another free seat in the training. And we have a very small number of seats left. So if those seats get full in the next couple days before we do the drawing in 10 days, then we won't be able to do the drawing because the class will be full. But we're going to do that drawing if we still have a seat left in 10 days. And so if you want to get into the drawing, go ahead and do that. If you want to get some of your coworkers registered, man, I tell you what, I know probably a lot of you haven't been to training in years. I know 2020 kind of squashed a lot of training for a lot of people. This is an amazing training. I really enjoyed delivering it. We have testimonial videos from so many people who came to the August class. Some of them are on our website. And it is a very advanced, immersive boot camp style training. And a half day is dedicated to AI driven development, as well as other skills and patterns that we need to know. So thank you so much for your attentiveness and for your questions. I love it. God bless you. Have a great day.